Let's draw a square with a side 1 and a circle so that it touches the upper and right side of the square and the bottom left corner of the square. Can you calculate this shaded red area? You can pause the video right now if you want to try this one for yourself. Alright, let's get to the solution. So first, our strategy will be to divide this complicated shaded red area into two pieces. First will be this down left piece, and the second will be this upper right piece. Let's first set our attention to this upper piece. We can get this area by finding the area of this orange circle, and from it we will subtract this blue segment. So, if we put this in our diagram, it will look something like this. Alright, now for the bottom part. We can get this bottom part by first finding the area of this green big square and then subtract the same blue segment from it. If we put this in our diagram, it will look something like this. Now we will add these pieces together. So, we will get our shaded area that will be equal to the area of our orange circle plus the area of the green square and minus 2 times the area of the blue segment. From here we will first take a look at this blue segment. If we first pull a line through the intersection points of the circle and the square, we can also see that this line will represent the diameter of the circle, and it will divide our blue shaded area into two separate segments. The first one will be this purple isosceles right triangle, and the second one will be the half of our circle. So we can now substitute these two segments instead of our blue segment. Now we can simplify our diagram a little bit more by showing these two segments individually. We will combine these two orange semicircles to form one full circle and these two purple isosceles right triangles to form a square. You can now notice that we have two identical orange circles, and since they are subtracting from each other, we can cancel them out. And that means that we are left with the following. So the shaded area will be equal to the area of our big square minus the area of this small, new formed purple square. Now we will try to find the side of this purple square. First we will mark the center of our circle, and we will pull a line from the center of our circle to the bottom left vertex of the square. This line will represent the radius of our circle. We can also mark the radius of our circle to the right side. Here you can see that these two radius are forming this yellow square. Now we will pull the diagonal of the square. Since the side of the square is equal to r, that means that the diagonal of the square must be equal to r square root of 2. And if we pull this green line that will represent the half of our diagonal, that green line will have the value of r square root of 2 over 2. Now we can pull another line from the center of the circle vertically up to the upper side of the square. This will also be the radius of our circle. Now, if you take a look at this green line, you can see that it is exactly equal to the side of our big square with a value of 1. So we can form our first equation. We can say that r plus r square root of 2 over 2 must be equal to the side of our big square, and that is 1. We can simplify this by multiplying with 2, and we will get the following. Now we can use r as a common factor from these two terms, and we will get that r times the quantity of 2 square root of 2 must be equal to 2. And that means that the r is equal to 2 over 2 plus square root of 2. Now let's again take a look at our sketch. We can draw another blue diagonal of this yellow square, and this diagonal will also represent the side of our purple square. So we can now say that the side of our purple square is equal to r square root of 2. If we substitute the value of r into our equation, we will get that the side is equal to 2 square root of 2 over 2 plus square root of 2. Now we can multiply this by a conjugate to simplify this even more. From here we will get the following. Now we will continue simplifying, and if we solve this, we will get the following. Here we can divide everything with 2, and we will get that the side of our purple square is equal to 2 square root of 2 minus 2. So now we have the value for the side of our purple square, and we already know that the value for the side of the big green square is equal to 1. Now we can form our equation. We can say that our red area is equal to the squared side of the green square minus the squared side of the purple square. If we substitute the value of our sides, we will get that the area is equal to 1 square minus quantity of 2 square root of 2 minus 2 squared. This second term will represent the binomial square, and we can solve it by using the formula that a minus b squared is equal to a squared minus 2ab plus b squared. If we apply this formula on our second term, we will get that the red area is equal to 1 minus the quantity of 8 minus 8 square root of 2 plus 4. We can simplify things underneath the brackets and we will get the following. Now, if we lose the brackets, we will get the final result that our red area is equal to 8 square root of 2 minus 11. Of course, if you want to, you can approximate this result to 0.31 squared units. And this is our solution. Hope you guys enjoyed this video. If you did, leave a like and subscribe to the channel for more content. And of course, until next time, see you guys and take care.